Your brand new Ford has multiple factory-configured settings engineered to prioritize corporate regulatory compliance and artificial low cost of ownership marketing metrics over the physical longevity of your engine and transmission. Most owners have absolutely no idea that by simply driving their truck or SUV exactly how it rolled off the dealership lot, they are actively accelerating the wear on critical mechanical components. The manufacturer tells you these systems are designed for efficiency and convenience. But my years on the shop floor tearing down prematurely failed engines tell a completely different story. Today, I am exposing 5 factory settings or features that are damaging your vehicle without you knowing. Setting number 3 has caused more catastrophic transmission fluid degradation and planetary gear failures in modern 10-speed units than almost any mechanical defect. And setting number 1 is so deceptive that owners actually think it is beneficial to their engine health when it is doing the exact opposite. Let's get into it. Setting number 5 is the factory-enabled auto start-stop system. Ford markets this feature as a seamless way to reduce emissions and save fuel at stoplights, leading you to believe it is a triumph of modern engineering. But here is what Ford doesn't tell you. Your engine relies on a principle called hydrodynamic lubrication. When your engine is running, the crankshaft spins inside the journal bearings, creating a high-pressure oil wedge that suspends the steel crank away from the softer bearing material. The clearance here is microscopic, often less than 0.001 of an inch. As long as there is movement and oil pressure, there is zero metal-on-metal contact. But the moment you come to a complete stop and that factory setting kills the engine, your oil pressure drops to 0 psi. The heavy crankshaft immediately breaches the residual oil film and settles directly onto the bearing shells. When the light turns green and the starter engages, the engine experiences boundary lubrication, which is a polite engineering term for metal grinding directly against metal until the oil pump can repressurize the galleries. A traditional vehicle without this system might experience 50,000 start cycle over its entire operational lifespan. A modern Ford with auto start-stop enabled is subjected to upwards of 500,000 start cycles in the same time frame. I have personally inspected rod and main bearings on 2.0-liter and 2.3-liter EcoBoost engines with fewer than 60,000 miles on the odometer, and the copper backing material was already showing through the aluminum matrix layer. That is wear directly caused by hundreds of thousands of unlubricated restarts. Furthermore, this constant cycling places immense thermal and mechanical stress on your timing chain components. Every single restart causes the chain to snap taut against the plastic tensioner arms, accelerating pin wear and causing the chain to stretch over time. When that chain stretches, your camshaft timing drifts, leading to poor combustion efficiency and eventually catastrophic valve-to-piston contact. The solution to this issue does not cost a dime, but it requires breaking the habit the factory wants you to form. You must make it part of your starting ritual to manually depress the auto start-stop disable button on your dashboard every single time you turn the key or push the ignition button. Alternatively, you can install a hardwired eliminator module that plugs into the switch or the diagnostic port to permanently command the module to stay off. Do not let a system designed to save a fraction of a gallon of fuel over a year grind your engine bearings to dust. Setting number 4 is one that the manufacturer markets as a high-tech convenience, but under real-world conditions. It is creating the exact environment that destroys your turbochargers and plugs your piston rings, the Intelligent Oil Life Monitor. Ford programs this system to calculate your oil change intervals based on software algorithms that track engine revolutions, operating temperatures, and drive cycles, frequently pushing the oil change reminder out to 10,000 miles or even 1 full year. They present this to you as a sign of advanced fluid engineering and low maintenance requirements. The mechanical reality inside a modern gasoline direct injection, or GDI, EcoBoost engine completely invalidates that 10,000-mile interval. Direct injection engines fire fuel at upwards of 2,000 psi directly into the combustion chamber. This process inherently causes a phenomenon known as fuel dilution, where raw gasoline washes down the cylinder walls and mixes with the engine oil in the crankcase. Gasoline is a solvent, not a lubricant. When your oil mixes with fuel, its viscosity shears down drastically. A specified 5W30 oil can easily degrade into a volatile 0W20 or thinner within just 4,000 miles of city driving, when you allow that sheared, fuel-diluted oil to remain in the engine for 10,000 miles. It can no longer support the thermal loads generated by your turbochargers. The center housing rotating assembly of an EcoBoost turbocharger operates at temperatures exceeding 400 degrees Fahrenheit under load. When thin, degraded oil passes through those glowing hot bearings, it undergoes thermal cracking. The oil literally cooks and turns into hard carbonaceous sludge, a process known as turbocoking. This sludge plugs the microscopic oil feed lines, starving the turbo bearings for protection and leading to total bearing seizure at the same time. This extended interval allows highly abrasive carbon soot, a natural byproduct of direct injection, to accumulate in the oil. This soot acts like liquid sandpaper, wearing down the precise tension on your oil control rings. Once those rings stick due to carbon sludge buildup, your engine will begin consuming oil at an alarming rate, baking that oil onto the intake valves and fouling the catalytic converters. I have pulled oil samples from trucks following the factory oil life monitor, and the total base number, the oil's ability to neutralize destructive acids, was completely depleted by mile 6,000. To prevent this invisible, cumulative destruction, completely ignore the dashboard prompt. Establish a strict, non-negotiable oil change interval of 5,000 miles or 6 months, whichever comes first. Use only a high-quality full synthetic oil that meets the latest Ford specifications, and pair it with a premium silicone anti-drainback filter. If you operate in heavy stop-and-go traffic or use your vehicle for towing, drop that interval to 4,000 miles. Your engine components will thank you with hundreds of thousands of miles of trouble-free operation. We have already exposed how the factory configurations on your dashboard are actively chewing through your engine bearings and turbochargers. Now, we need to dive deeper into the drivetrain and cooling systems to look at two even more deceptive settings that are directly responsible for multi-thousand-dollar component failures. Setting number 3 is the factory transmission logic profile known as skip-shift programming, combined with extended fluid service intervals. If you own a modern Ford equipped with the 10R80 10-speed automatic transmission, you have undoubtedly noticed that under normal acceleration, the gear indicator on your dash jumps directly from first to third and then from third to fifth gear. Ford engineers this behavior into the transmission control module to keep engine RPMs as low and static as possible during light load acceleration, which satisfies corporate laboratory fuel economy testing. But out here in the real world, this skip-shift strategy forces a massive mechanical compromise inside the transmission case. To bypass second and fourth gears smoothly, the transmission must slip the incoming clutch packs under high torque load to match the wide ratio gap between those non-sequential gears. Instead of a crisp immediate engagement, the internal friction plates are forced to grind against one another for fractions of a second longer during every single shift cycle. This intentional slipping generates intense, localized thermal spikes right at the friction surfaces of the clutches. This localized heat exceeds 600 degrees Fahrenheit in microseconds, instantly scorching the transmission fluid that flows through the clutch packs. Over time, these microscopic heat spikes cause the fluid to oxidize, breaking down its shear stability and depleting the anti-shudder additives long before the factory-recommended 150,000-mile service interval. As a veteran technician, I can tell you that leaving your transmission fluid in the case for 150,000 miles while the skip-shift logic cooks it daily is financial suicide. By the time that fluid reaches 60,000 miles, it is often completely black, smelling of burnt organic material, and saturated with microscopic metallic debris from the wearing clutch plates. This suspended friction material is highly abrasive. It travels straight into the main valve body, scoring the aluminum bores and causing the solenoids to stick. Once those solenoids stick, your smooth shifts turn into violent, metal slamming hesitations. Even worse, the oxidized fluid can no longer properly lubricate the needle bearings inside the planetary gear sets, causing the gear teeth to pit, spall, and eventually shatter, sending chunks of hardened steel straight through the entire gear train. The solution to saving your 10-speed transmission requires a two-pronged approach. First, you need to change how you drive the vehicle. When you are operating in heavy traffic or pulling any kind of load, manually select Tow.Haul or Sport Mode using your Drive Mode selector. These factory-programmed modes alter the transmission logic, forcing the transmission to use every single gear sequentially, first, second, third, fourth, completely eliminating the high-wear skip-shift strategy. Second, cut Ford's absurd 150,000-mile fluid maintenance schedule down to a realistic 40,000 to 50,000 miles. Have a qualified technician perform a pan-drop fluid and filter exchange, never a high-pressure flush, to remove the suspended clutch debris and replenish the fluid's thermal protection properties. Setting number 2 is the active grille shutter, default calibration. Walk up to almost any late-model Ford truck or SUV, and behind the main cosmetic grille, you will find a motorized assembly of plastic horizontal blinds. These shutters are controlled by the powertrain control module, which keeps them entirely closed during cold starts and highway cruising. Ford markets this feature as an aerodynamic enhancement that cuts drag and speeds up engine warm-up times, supposedly optimizing efficiency. But here is the underlying mechanical reality. Keeping those shutters closed traps an immense amount of latent heat inside the engine bay, driving under-hood temperatures to extreme levels that accelerate the degradation of every plastic, rubber, and electronic component under that hood, while your dashboard temperature gauge stays reassuringly pinned right in the middle, because Ford designs that gauge with a massive dead band that doesn't move until the engine is practically melting. The actual cylinder head temperatures are secret, lie fluctuating into dangerous territory. Modern EcoBoost engines utilize aluminum cylinder heads bolted to aluminum engine blocks. Separated by a multi-layer steel head gasket, aluminum expands and contracts dramatically with thermal changes. When the active grille shutters stay closed to chase a fraction of a percent of aerodynamic efficiency, the cylinder head develops localized hotspots. This creates uneven thermal expansion across the deck surface, putting immense physical stress on the head bolts and the head gasket sealing rings. Over time, this cyclic thermal stress causes the head gasket to relax its clamping force, allowing high-pressure combustion gases to breach the sealing ring and erode the aluminum deck. Furthermore, this trapped heat completely cooks the plastic coolant connector fittings at the back of the cylinder head, making them extremely brittle. Eventually, one of these brittle plastic clips snaps under pressure, causing an instantaneous, catastrophic loss of engine coolant that destroys the engine before you can even pull over to the shoulder. I have worked on countless vehicles where the active grille shutter motor or linkages binding caused the shutters to stick completely closed. And because the vehicle didn't immediately trigger a check engine light, the owners drove them for weeks in a state of chronic overheating. The plastic valve covers warp, the ignition coil boots bake until they crack, and the wiring harnesses become so brittle that the insulation crumbles away at the slightest touch. The solution to this engineered heat trap is to modify the system's operation. While you can completely remove the plastic shutter blades entirely, without causing a mechanical restriction, an easier approach for most owners is to use an electronic diagnostic tool like ForScan to reprogram the PCM parameters, or simply unplug the shutter actuator motor assembly while the shutters are manually locked in the full open position. This ensures a continuous, uninhibited stream of fresh, ambient air across your radiator, intercooler, and auxiliary coolers at all times, stabilizing your actual cylinder head temperatures and preventing the slow thermal cooking of your entire engine bay. We have already targeted the hidden traps in your starting routine, your oil life monitor, your transmission programming, and your cooling system. Now we have arrived at number 1, the most deceptive, mechanically destructive factory setting in the entire vehicle. And it is something you probably look at every single day thinking it is a sign of a perfectly healthy engine. Setting number 1 is the factory-programmed engine oil pressure switch and its corresponding dummy gauge on your instrument cluster. If you look at the dashboard of your Ford truck or SUV, you will see an oil pressure gauge with an icon of an oil can, featuring a needle that sits beautifully right in the middle of the normal range whenever the engine is running. Ford designs this visual display to give you peace of mind, leading you to believe that a sophisticated electronic sensors is actively monitoring the real-time lubricating pressure of your engine oil across all RPMs and loads. The mechanical and electronic reality behind that dashboard needle is a complete fabrication. There is no active pressure transducer communicating variable data to that gauge. Instead, your highly advanced engine relies on a cheap binary pressure switch screwed into the engine block that is calibrated to trigger at a shockingly low threshold, typically between 5 and 7 psi. If your engine oil pressure is anywhere above that microscopic threshold, the switch closes, sends a generic signal to the body control module, and the software commands that dashboard needle to jump straight to the dead center position. Whether your engine is producing a healthy 45 psi at highway cruise or a critically deficient 8 psi while idling hot in traffic, that needle does not move a single millimeter. It is a simulated indicator designed solely to prevent customer complaints and keep you completely oblivious to the slow internal starvation of your valve train and bearings. This deceptive programming is exceptionally dangerous on modern Ford engines utilizing variable camshaft timing, or VCT, systems. Your camshaft phasers, solenoids, and chain tensioners are entirely hydraulic. They require high, consistent oil pressure and volume to advance and retard the engine timing accurately. As these engines age, internal wear on the oil pump housing or the widening of bearing clearances naturally causes oil pressure to drop. When your actual oil pressure drops down to 12 or 15 psi at hot idle, which is far too low to reliably operate the VCT phasers or keep E-timing chain tensioners fully extended, the factory dashboard gauge still points proudly to the middle. Because you see a perfect reading on the dash, you continue driving the vehicle normally. Meanwhile, inside the front timing cover, the lack of hydraulic pressure causes the heavy camshaft phasers to physically slam against their internal locking pins during every rotation. This constant mechanical pounding shatters the internal phaser vanes, sending hard plastic and metal fragments down into the oil pan where they plug the oil pump pickup screen, further starving the engine. The chain tensioners relax, allowing the timing chain to whip violently against the guides, fracturing them into pieces. I have torn down dozens of EcoBoost and Coyote engines where the valve train was completely destroyed by chronic low oil pressure, and in every single case, the owner told me the exact same thing. The oil pressure gauge on the dash said everything was fine right up until the engine threw a rod. The solution to this engineered blind spot requires you to step outside the factory display architecture. If you want real protection, you must install a physical or electronic aftermarket gauge that reads true, live data directly from the oil galleries. The most non-invasive way to achieve this on modern Fords is to utilize a digital monitor or an OBD2 scan tool interface that communicates with your phone or a dedicated auxiliary screen. This allows you to monitor the actual oil pressure PIDs that the engine control module uses internally, rather than relying on the sanitized dummy needle on your cluster. If you ever see your hot idle oil pressure dip below 20 psi on a modern multicam Ford engine, you know immediately that you have an underlying issue with oil dilution, viscosity shear, or mechanical wear that must be addressed before it results in a catastrophic engine failure. Taking control of your vehicle's longevity means recognizing that the factory settings are optimized for the manufacturer's balance sheet, not your wallet. The auto start-stop system, the extended oil life intervals, the skip-shift transmission profiles, the closed active grille shutters, and the deceptive oil pressure dummy gauges are all pieces of a corporate puzzle designed to get your vehicle past its factory warranty expiration date with minimal maintenance costs on paper, leaving you to hold the bag when the cumulative invisible damage finally manifests as a major mechanical failure. You do not have to accept these engineered lifespans. By breaking the factory-directed habits, by manually disabling start-stop, cutting your fluid service intervals in half, selecting sequential drive modes, unlocking your cooling airflow, and monitoring your true engine data. You shift the power back into your own hands. You leverage your own preventative maintenance to completely bypass the service department traps that catch millions of unsuspecting owners every year. If this deep dive consultation gave you the raw, unfiltered truth you need to protect your investment and save thousands in unnecessary repair bills, subscribe to the channel right now. We strip away the corporate marketing and deliver the hard, hands-on mechanical realities every single week so you can keep your vehicle on the road and out of my shop. Stay vigilant, check your actual fluid conditions, and drive smart.